Hello Year 8. I'm sorry I can't be with you today, but you will have a cover teacher, I'm sure. And today we're going to look at concentration and pressure. It's going to be a video lesson. So to begin with, what I'd like you to do is I'd like you to draw a particle diagram for the first glass and the last glass in this diagram of squashes here. Can you explain why the first glass and the last glass are different using particle diagrams? Pause the video, have a think about that, draw it out nice and neatly in your exercise books with a title, and then we'll run through the answer in a moment. Okay, let's run through some answers to this. This diagram on the left-hand side here is like the first glass of squash on the previous slide, whereas this diagram on the right-hand side is like the last glass of squash on the previous slide. And hopefully what you can see here, the difference between these two diagrams, is here this is a dilute solution because you haven't got many solute particles. We'd think about those solute particles as being squash particles. Whereas in the diagram on the right-hand side, you've got a great deal of solute particles, that is to say squash particles, in the solution. So this solution here is concentrated, whereas this solution here is dilute. So the diagram on the left is less concentrated, or you could say it's more dilute. This is because there are fewer solute particles in the same volume, in the same space. Whereas the diagram on the right is more concentrated. This is because there are more solute particles in the same volume, the same space. So the cover teacher is now going to pause the video. If you need to add that to your notes, please do. You may not have used the terms such as solute. Solvent would be the water, so the solute is the squash. The solvent would be water, and the result is a solution. This is a dilute solution. Usually you'd say weak squash in everyday language, but we don't say weak, we say dilute. Or concentrated, you'd say strong, but you shouldn't use the word strong, you should say concentrated. The cover teacher will pause the video and give you a few moments just to update your notes if you need to. Okay, so let's look at our objectives for today. By the end of the lesson today, what I hope is that you'll be able to use the particle model to explain the differences in concentrations and solutions. Indeed, that's what we've just seen on the previous slide. We also need to be able to describe, to say what is meant by concentration and what is meant by pressure. And finally, we need to be able to describe how concentration and pressure can be increased. So what is concentration then? Well, concentration, put simply, is the number of particles in a certain volume, in a certain space. People often use the word space or area when really what they should be using is volume, because space has both height, width and depth. How can you increase the concentration of a substance? Well, you can increase the number of solute particles, as we showed in our diagram of the particles in a dilute and concentrated glass of squash, or you could reduce the amount of solvent. Amount is a very woolly word. You need to say the volume of the solvent. So thinking back to those glasses of squash, you could either put more squash in that volume, so you could top up the level of squash, or you could reduce the volume of water that you're adding to that squash to make it more concentrated. So in terms of a mathematical expression for concentration, concentration is measured in a variety of ways, but what I want you guys to get your head around is it's the mass in grams in a certain volume, and that volume is centimetres cubed. So we take the mass in grams of a substance and we divide it by the volume in centimetres cubed. Please can you make sure that you've got this down in your notes, and in just a moment we'll go through an example calculation. So please pause the video and then we'll go through an example calculation. Okay, hopefully everybody's now got this down in your notes. Here's an example calculation using this formula here, this mathematical expression here, to work out the concentration of a solution. So let's say I make a salt solution. I take 30 grams of salt and that's added to 100 centimetres cubed of water. What's the concentration? Well, the mass will be 30 grams and we need to divide that by the volume, which will be 100 centimetres cubed. So to lay out our calculation and to show all of our working, which is really, really important, in every calculation, please show all of your working. So to show our working, we've got 30 grams, which is our mass of salt, divided by 100 centimetres cubed of water. When we do that and plug that into our calculator, we use 0.3 grams per centimetres cubed. That is the concentration of the salt solution. Again, can you pause the video? Can you make sure that this example is in your notes? Because it's going to be important for what you're going to do next, which is some practice questions on this. Okay guys, I'd like us to have a go at some practice questions using the equation that we've just written down. There are 4 questions on the screen. Practice, of course, makes perfect. I'd like you to calculate the concentration of each of those solutions. Please can you remember to show all of your working, including writing down the units, that is to say what each thing is measured in as you work through the calculations. You should have a scientific calculator with you, but I'll leave it up to the cover teacher as to whether they'll allow you to use your mobile phone if you have forgotten your scientific calculator. If you don't have your calculator with you, please can you make sure you bring it to each and every single lesson. It is an important part of your equipment. I'll run through the answers shortly. Okay, here are the answers. The first question, 5 grams of sugar dissolved in 20 centimetres cubed of water. It's 5 grams divided by 20 centimetres cubed of water, which is 0.25 grams per centimetres cubed. 15 grams of salt divided in 25 centimetres cubed of water is 15 grams divided by 25 centimetres cubed, which is 0.6 grams per centimetre cubed. 10 grams of cordial dissolved in 200 centimetres cubed of water will be 10 grams divided by 200 centimetres cubed, which is 0.05 grams per centimetre cubed. And lastly, 5 grams of acid dissolved in 5 centimetres cubed of water is 5 grams divided by 5 centimetres cubed, which is 1 gram per centimetre cubed. Well done if you got all those right. Tick them off if you got them right. Write in the answers, including the working in your exercise book nice and neatly, please. Thank you. Okay, next little thing then. There are some images on the screen. What I'd like you to have a chat about is what do all of these objects have in common? I'd like you to use scientific keywords to explain your answer. And explain secondarily what would happen if there was a hole in each of these objects. Pause the video and have a little think, making some notes down in your books so we can go through the answers shortly. Well, hopefully what you said is that all of these objects contain compressed gas particles that are stored under a very, very high pressure. So what would happen if you punctured a hole in these objects? Well, they would deflate very, very quickly. Some people might describe that as explode, but they would deflate very quickly because they're under high pressure, and that high pressure means that there are lots of particles inside that container which are bouncing around inside that container. And when you release that pressure, when there's a little hole in it, all of that pressure will come shooting out. All of those air molecules or gas molecules will come shooting out of the container quite catastrophically. So bearing that in mind, guys, what I'd like you to do, first of all, is to draw a diagram of some gas particles inside some sort of closed box container. I'm not very good at drawing. I'm not asking you guys to be, but make sure that we use a nice sharp pencil and a ruler. And I want you to, once you've got that diagram, I'd like you to suggest how the air pressure inside that container could be increased. And I'll give you a bit of help in just a moment with that, but pause the video for now and have a go at both of those things on the screen. Okay, hopefully what you will have recognised is the more times the gas particles hit the walls of the container, the higher the air pressure will be. So using that information, if you haven't as yet had a go at the second part of this what's on the screen, I'd like to do so. A bit of a hint, there are 3 things that you could do to increase the air pressure. Pause the video and give it a go. Right guys, what you could do is you could add more particles of air, so you could pump more air into your container. You could decrease the volume of the container, which ultimately means that you're going to use a smaller container. Or you could increase the energy of those particles, which would mean heating it up, in other words, increasing the temperature. Well done if you said all of those. If you didn't, please can you add those to your notes? Again, the cover teacher will pause the video to allow you to do so. And then we'll finally have a go at some questions before I run through the answers. Right, so here's some little questions that I'd like you to have a go at a plenary to finish off today's lesson. If you want to explain your answers using a diagram, that would be a fantastic thing to do. And when I go through the answers, I'm looking for scientific keywords to have been used. Right, so please bear that in mind. Diagrams, keywords, and can you make sure that you're writing out the questions as well, guys, so that when you're revising, it's obvious what the question was, to really help you to get the best possible results on any test that we do. Well done. I shall run through the answers when you're ready. Okay, here's some answers. How can air produce a pressure? Well, a pressure is caused by a force, and there's 2 means by which air particles can create a force. They create a pressure due to the weight, which is a type of force, of all of the air molecules above. So when you're outside, there's a huge volume of air above you, and that's weighing down on you. That's creating a pressure. But air molecules also create a pressure when they're placed in a container, as you saw from your diagram that you drew of the particles inside a box. Because what happens is that they create a pressure by moving about and repeatedly hitting the wall of that container. Why then does air pressure increase when you pump up a tyre, such as a bicycle tyre or a car tyre? Well, when you pump air into a tyre, the air particles move about and hit the wall of the tyre, just as we've talked about here. And as you pump more air into the tyre, you're going to get more air particles which hit the wall of the tyre. That's going to increase the pressure. Can you pause the video, guys? The key thing, you might have written this in a slightly different way, but the key things are in bold here. So can you make sure that as part of your answers, you've got the key things in bold written down? And then we'll go through the answer to question 3 and finally question 4. Okay, the answer to question 3. Use particle theory to explain why a tyre gets bigger when you pump it up. Well, here's a nice little diagram here. As you pump more air into a tyre, more air particles hit the wall of the tyre. That means that the tyre increases in volume. So here, this is a car tyre at low pressure. There aren't many particles on the inside of the tyre, so they're not going to hit the sides of the wall of the tyre very frequently. So these grey arrows here represent the pressure of those air particles hitting the side of the wall of the tyre. So this is at low pressure. But as you increase the number of air particles inside the tyre, that means you're going to increase the pressure because there are going to be more collisions with the side of the container. So as you increase the air pressure inside the tyre will increase in volume. It will inflate. So you go from this situation here to this situation here. The pressure is getting larger. That means that the car tyre is going to get larger in size. The second part B, why a tyre gets smaller as you let out the air. Well, you're going from this situation here to this situation here. It's exactly the opposite. As the air is released from the tyre, you've got less air particles inside the tyre, and they're going to hit the wall less frequently as there are fewer air particles. So that means the tyre decreases in volume. So again, please can you pause the video and add to your notes as necessary. Okay, last question, question 4. Explain how air pressure helps you to drink through a straw. Well, I've supplemented this with a little diagram. And when you drink through a straw, what you're doing is you're removing some of the air in the straw. So the pressure inside the straw is reduced. It's less than atmospheric pressure. And atmospheric pressure is the force of those air particles bashing down on the surface of the liquid. So that means the pressure outside of the straw is going to be greater than the pressure inside of the straw. So atmospheric pressure is going to push the liquid up through the straw and into your mouth so that you can drink whatever is in the glass. Again, pause the video and add to your notes, just remembering that the bits in bold are the really key parts. Well done, guys. We've come to the end of the lesson. So if you've finished, you should be able to write down 3 key things you've learned today. What other questions do you have as well? What do you feel confident on? There are those 3 objectives down here that we looked at the start of the lesson: to use the particle model to explain the differences in concentrations of solutions, to describe what is meant by concentration, which is to do with solids being dissolved in liquids, and pressure, which is to do with the amount of gas particles in a certain volume. And you need to be able to describe how concentration and pressure can be increased. Rate these objectives: red for I'm not sure, amber I'm kind of okay, and green for yes, I feel very confident about those. Any problems, message me through Teams. This should, I would think, take you this whole thing about 15 minutes or so. Well done, guys, and I shall see you next week.